Hi guys, my name is Sabra Attia and this is PEARSON EDEXCEL 2019 M1. Very important notes before solving M1. A numerical answer which comes from G equal 9.8 should be given to 2 or 3 significant figures. It means the final answer will be decimal, not fraction. Decimal form, not fraction form. It's okay. Number two, the measure of angle in radian is better than degree. It means if the answer, if the question about angles, it's better to find in radian form better than degree form. Here is a modeling of some situations, something like this. Straight lines are assumed to be inextensible. This means that when the string becomes taut, any particle move in straight line connected at either end move at any instant with the same velocity and acceleration. And number two, another situation. Number three, another one. Number four, number five, and number six, number seven, and eight. These are the most important situations. You should memorize them by heart. Let's start the exam. Two particles P and Q have masses 3m and 2m respectively. They are moving in a straight line in opposite directions towards each other on a smooth horizontal plane and collide directly. The speeds of P and Q immediately before the collision are 2u and 4u respectively. As a result of the collision, the speed of P is halved and its direction of motion is reversed. Find the speed of Q immediately after the collision. Let's see how to solve it. Solve the problem, we draw it, and we take an initial direction as positive direction, and this the velocity before collision, and this the velocity after. So replace and then simplify. Replace m1 which is 3m, u1 which is 2u in positive direction, m2 which is 2m, u2 in opposite direction of the positive one, so will be negative for u as you see, and here m1 3m and v1 the speed answer the speed after the collision is halved the before and in opposite direction, so will be negative u as you see, and m2 is 2m as you know, and vq the speed of q after collision we don't know. Then to simplify, 3 times 2 will be 6, 2 times 4 will be negative 8. Now we have 6 mu minus 8 mu will be negative 2 mu, and here we have 3m multiplied negative u will be negative 3 mu plus 2 mvq. And then using now we can remove m from all parts as if we divided the whole thing by m at negative 2u plus 3u equal to vq. So negative 2u plus 3u will be 1u as you know. Divide by 2 gives us vq equal half u. So the velocity of q will be positive. Q it was in negative direction. The answer after collision is positive, so Q reversed its direction. It's okay. I hope you got it. Part B, find the magnitude of impulse exerted on Q by P. Impulse rule, I equal m multiplied by v minus u. V the velocity after minus u velocity before. So m will be 2m the mass of q multiplied by the velocity after which is half u minus the velocity before negative 4u. So 2 multiplied by half minus minus 4, it means half plus 4 which is 4.5 Now we have 2 times 4.5, which is 9. 9 m by u will be 9 mu. I hope you got it. Question 2. Here is a broom of mass half kilogram, and this handle of the broom modeled as a light rod, so there is no mass for the handle of the broom. And there is the handle of the broom make angle 40 with the horizontal, as you see, and the coefficient friction between the broom and the head of the floor is quarter. This coefficient friction, this mu, and the broom head is pushed along the floor in a straight line at constant speed. Find the magnitude of the force that is being applied along the handle of the broom to the broom head. Let's see how to solve it. To answer, first step, we draw the problem. This is the figure that we can say in the question itself. So this is the handle of the broom, this 40 angle, this is the mass of the broom, which is 0.5 kilogram, as you see. After that, we factorize the forces. It's okay. This force that push the broom make angle 40. So we write it in horizontal part P cosine 40 and vertical part P sine 40. So this V vanished now and come in two parts, vertical one and horizontal one, and in its direction, as you see. The broom tends to move in this way, so the friction force in opposite direction. So in opposite direction, this is the friction force, which is equal mu r. And now we have the weight downwards. The normal reaction will be upward, as you see. These the total forces act on the broom. It's okay. Now we resolve them vertically. As you know, as you see, in vertically P sine 40 downward and the weight of the body 0.5 g downward are in opposite direction upward. So we can write r equal P sine 40 plus 0.5 g, this first equation. Then resolving horizontally. Horizontally, as you see, P cosine 40 opposite to the friction force. So we can write P cosine 40 equal friction force, which is mu r, and r from first part equal B sine 40 plus 0.5 g. As you know, mu equal quarter from the problem itself. It's okay. Then, so we replace mu for quarter. Now we have cosine P cosine 40 equal quarter B sine 40 plus 0.5 g. Then expand or distribute the quarter into component. Now we have P cosine 40 equal quarter P sine 40 plus quarter by half 1 over 8 g. Combine like terms or collect them. So we have P cosine 40 minus quarter B sine 40. After that, take B as a common factor. So we have P cosine 40 minus quarter sine 40 equal 1 over 8 g. We want to find value of P. So divide 1 over 8 g over cosine 40 minus quarter sine 40. Write the whole thing on your calculator to get the answer. Question 3. This is a beam of 8 meters, as you see, kept horizontally by two ropes, one at C and the other at D, and the distance AC equal half meter and BD equal half as well. And there is a gymnast at P such that AB is 2 meters, as you see. The mass of gymnast is M, is unknown, and the tension at D is 637. The required is find M and the tension at C. Let's see how to. And this beam of 100 kilogram. It's okay. First step, we draw a problem. The gymnast act as a particle, so its weight will be mg. It's okay. And the tension at C will be Tc. The tension at D 637 is given. The total length of AB is 8 meter. Here is half and here is half. As the total AB is 2, so this part will be 1.5, and AB is uniform, so its weight will be in the middle. So this 4 and this 4, because the total length, as you know, is 8. So this half, so we have here 3.5, and this AB is 2, so this part will be 2 as well. Now we can take the moment about this part. So this force will be vanished, okay? mg downward, 100g downward, and 637 upward. So we can write mg multiply the distance, which 1.5, plus 100g multiplied by the total distance from C to the midpoint, which is 2 plus 1.5, which is 3.5, equals 637 multiplies distance from D to C. The total length was 8. I was 8. The total length is 8. This part is half and this part is half. So CD will be 7. Half and half is 1, as you know. Then we can find M by using inverse operation. 637 multiplied by 7 minus this part will be by minus 100g multiply 0.5 over 1.5, using your calculator to get the value of M, which is 70 kilogram. This first part. Second part, we need the tension at C, so we can using resolving vertically, TC upward and TD upward as well, and 100g downward, and the mg, which is 70g. Now we know the value of M downward, so we can write upward equal downward. TC plus 737 equal 7g plus 100g, using inverse operation. 70 plus 100 will be 170 minus 637. Now using calculator to get the answer, which is 1029, which is 1029 approximately 1030 Newton. It's okay. As a matter of fact, we should write this for 1030 to be series significant figure. As you know, calculation using G should be 2 or 3 significant figure. So this is very important. It's okay. Let's see next part. Number B, state how you have used the fact that the beam is modeled as a rod. So it has the same length and still straight line form. Last part, the gymnast at P now gets half of the beam and replaced by 2 gymnasts. One gymnast of mass 60 kg stands on the beam at B, and the other gymnast of mass 48 stands on the beam at X, where X meter. The beam remains horizontally on the equilibrium, but the tensions on the 2 ropes are now equal. The 2 gymnasts are modeled as particle. Find value of X. Let's see how to solve it. Now the 2 tensions are equal, so at C will be T and at D will be T as well. The 2 gymnasts, one of 60 kg and the other of 48 kg. The beam is still uniform, so the weight in the middle, as you know. So we can resolve vertically. We have T upward and here another T. So we have T plus T equals the downward 60 kg, 100 kg, 48 kg can be written in this form or multiplied by G to get the weight. So T plus T will be 2T. To get T, divide the whole thing by 2 to get the answer. As we said before, the answer should be 2 or 3 significant figure, so the answer will be 1020 Newton. Now try to find the value of x. It's okay. We take the moment about c, so this part will be vanished. We have 3/4 downward and 1/4 upward, so we can write the 3/4 downward in a side equal the opposite one. Now we have 60g multiplied by 1.5 because we talk about c now. Then 100 multiplied by 2 plus 1.5 will be 3.5 plus 48 multiply cx. It's okay. We take the moment about c, so this will be cx. Got it? In the other part, we have the tension, but the right value of tension. It's okay, not the approximated one, because this is not final answer. It's a part in a question, part of an answer. It's okay. Then using inverse operation, this will be the same. This will be by minus, and this part will be by minus. Okay, and this part will be by minus, and this will be divide, using divide to get cx. So cx equal 6. The question about ax, not cx. So this part from here to here, cx is 6 and the ac is half, so x equal 6.5. I hope you got it. It's C1. Question 4. A real truck of mass 500 kilogram. This the truck pushed up a straight track. This is straight track. Viral engine of mass 2000 kilogram. This is engine of 2000 kilogram. The tracking current is horizontal by angle theta, where sin theta 1/14. The engine produces a constant driving force magnitude 3050 Newton. The truck experiences a constant resistance to motion of magnitude 100 Newton, and the engine experiences a constant resistance to motion of magnitude 200 Newton. The engine and the truck are connected by coupling, which model does a light rod that is parallel to the track. Find the acceleration of the system, the magnitude of forces exerted on the truck by the coupling. Let's see how to solve it. We can model the problem. Now we have force of engine upward of magnitude 3050, opposite to the component of weight of first body, which 2000 g multiplied by sine of the angle, which 1/14. Also opposite to the component of weight of the second body, which is 500 g multiplied by sine of angle 40, which is 1/40. Also opposite to the friction force for first body and second body, 100 and 200 Newton. The total thing equal, as you know, MA M 2000 plus 5000 plus 500, sorry, which will be 2500. This is the total mass of the system multiplied by A, the acceleration. Then using calculator part left side in your calculator, which will be 1000, then divided by 2500 to get the acceleration. So the acceleration will be 0.4 meter per second square, as you know. This first part. Separation of motion for the truck only, this part. For the truck only, the push upward, so the push upward, opposite to the friction force, which is 100, and the component of weight, which will be 500 g multiplied by sine of angle theta, which 1/14, equals the acceleration from first part, 0.4, multiplied by the mass, which is 500. Using inverse operation to get P will be 650 Newton. I hope you got it. Question 5. Two forces F1 and F2 act on a body. The resultant of the two forces is R. Given that R has the same direction of the vector 3i negative 2j, find the size of angle between R and the vector j. the vector 3i minus 2j in fourth quad, as you see. So theta will be 90 plus arctan 2 over 3. Using your calculator to get the answer. It's better to find it in radian. So multiply the answer by pi, divide 180, you get the answer in radian 4. Given at F1 equal AI plus 3j Newton and F2 equal negative 4i plus bj Newton, show that 2a plus 3b plus 1 equal 0. Let's see how to solve it. R equal F1 plus F2. So R equal AI plus 3j plus 4i minus bj. Combine like terms. Now we have a minus 4i plus 3 plus bj and r parallel to 3i minus 2j. Since they are parallel, so the slope are the same. So j over I equal j over I. Now we have 3 plus b over a minus 4 equal negative 2 over 3. Do cross multiplication to get 3 multiplied by 3 plus b equal negative 2 multiplied by a minus 4. Distributing 3 by 3 will be 9, 3 by b 3b. Also negative 2 by a, negative 2a, negative 2 by 4 will be 8. After that, get the 0, 4. So we have 9 plus 3b plus 2a minus 8. 9 minus 8 will be positive 1. I hope you got it. Question 6. A small ball is projected vertically upward with speed u meter per second from point A, that is 12.5 meter above the horizontal ground. The ball moves freely under gravity until it hits the ground 25/7 seconds later. By modeling the ball as a particle, find the value of u. We can draw the problem. The body is 12.5 above the ground, so projected from point A, it come up, then after a while it come back downward, as you know. So the distance will be negative 12.5. The acceleration, the body project upward, so the A will be in negative. Time is given 25/7 is given in the problem. Using the equation s equal ut plus half a t squared, replace. Now we can, using your calculator, simplify, as you know. Now we're using inverse operation to get value of u. So u will be 14 meter per second. It's okay. I hope you got it. After hitting the ground, the ball rebounds vertically and come to instantaneous rest at point B 5/7 seconds after hitting the ground. Find the height of B above the ground. Let's see how to solve it. The ball hits the ground and move up to the point B. So at the point B, velocity will be 0. The body move up, so A will be in negative 4. T is given in the problem 5/7. Use the equation V equal UA plus AT to get U. Then use the equation V squared equal squared plus 2AS. V will be 0 as we said. U will be 7, we get it now. And A will be in negative 4. Replace and using inverse operation to get the value of S, which is 2.5. I hope you got it. Number C, sketch the velocity time graph for the motion of the ball from the instant when it was first projected from A to the instant when it comes to instantaneous rest at B. Let's see how to solve it. We can draw the total motion of the body. First, move to up to a point, then come to V equals 0, then move downward, then hit the ground and come upward another time. We talk about the velocity now. When the body move up, the velocity is positive. Start with 14 meter per second. come to 0, then reverse its motion. The direction is negative but increasing. Then hit the ground and move to up. The velocity is positive but decreasing as well. So the velocity here something like 7 and come to 0. So we can draw each part. First part in positive. So this red one, it will be here is positive. V is positive. And this green one, the velocity is negative. So the velocity will be downward. The point here, dear friends, in this, the body come to hit the ground first when it come in negative direction and rebound upward in positive direction. The yellow part, it means the velocity is positive. The body move upward is velocity is positive, so the yellow part will be in positive part of velocity. I hope you got it. Question 7. A ship A is moving with a constant velocity to I minus 14 km per hour. At TPM, the position vector of ship A is 8I plus 7j km. Another ship B is moving with a constant velocity 12I minus 4j km per hour. At TPM, the position vector of B is I plus 2j km. Show that the time t at a time t hour after 2 p.m. BA vector equals 7I minus 10ti plus 5 minus 10tj kilometer. Let's see how to solve it. As you know, for the shape A, the position vector equal 8I plus 7j and the velocity equal 2I minus 14j are equal the position vector plus vt, as you know. So R equal 8I plus 7j plus t 2I minus 14j. Then we combine like terms to get the form I and j. So 8I plus 2ti will be 8 plus 2ti in this form. 7j plus t multiply negative 14j equals 7 minus 14tj. So this is the position vector of the ship A at any time. For the ship B, the same thing. We have R equal R naught plus VT. So equal I plus 2j plus t multiply 12I minus 4j. Combine like terms to get the position vector of B. BA, as you know, BA equal RA minus RB. Then combine like terms to get 8 plus 2t minus 1 plus 12t. So minus will be distributed, it will be minus 1 minus 12t, as you know. Then do 7 minus 14t minus the second component and distribute the negative will be negative plus 4t, negative 2 plus 4t. Then simplify to get BA equals 7 minus 10t I plus 5 minus 10t j. I hope you got it. Let's see next part. Hence, find the length of time for which the ships are within 2 km of each other. Take care, dear friends. The question, the length of time in which the ships are within 2 km. It's okay. Not, question isn't not, find the time when the ship 2 km. I hope you got the point. Here we have the position vector AB, which is 7 minus 10ti plus 5 minus 10tj. So we can find the norm, as you know, square root and first projection power 2 plus second projection power 2, which is equal to 2 km. It's okay. So we expand, we can put power 2 here and power 2 here, square both sides, as you know, and expand the bracket, the first bracket and second one, as you know, first power 2, second power 2, first by second by 2, as you know. Then combine like terms to get 200t squared minus 240t plus 70 equal 0. We can divide the whole thing by 10 to make it simplified. 20t squared minus 24t plus 7 equal 0. Then factorize this form. 20 will be 10 times 2. 7 prime number will be 7 by 1, and the last sign is positive, so we get two similar signs, negative and negative, like the middle, as you know. So we have either or. Either 10t minus 7 equals 0, it means t equals 7 over 10, or 2t minus 1 equals 0, it means t equal half. So in this time and this one, the two ships at 2 kilometer apart. Ships is within 2 kilometer. We'll do subtract for the 2 times to get the length of the time. I hope you got it. Question 7. A ship A is moving with a constant velocity to I minus 14j km per hour. At TPM, the position vector of ship A is 8I plus 7j km. Another ship B is moving with a constant velocity 12I minus 4j km per hour. At TPM, the position vector of B is I plus 2j km. Show that the time t at a time t hour after 2 pm, BA vector equals 7I minus 10ti plus 5 minus 10tj kilometer. Let's see how to solve it. As you know, for the ship A, the position vector equal 8I plus 7j, and the velocity equal 2I minus 14j are equal the position vector plus vt, as you know. So R equal 8I plus 7j plus t 2I minus 14j. Then we combine like terms to get the form I and j. So 8I plus 2ti will be 8 plus 2ti in this form. 7j plus t multiply negative 14j equals 7 minus 14tj. So this is the position vector of the ship A at any time. For the ship B, the same thing. We have R equal R naught plus VT, so equal I plus 2j plus t multiply 12I minus 4j. Combine like terms to get the position vector of B. BA, as you know, BA equal RA minus RB. Then combine like terms to get 8 plus 2t minus 1 plus 12t. So minus will be distributed, it will be minus 1 minus 12t, as you know. Then do 7 minus 14t minus the second component, and distribute the negative will be negative plus 4t, negative 2 plus 4t. Then simplify to get BA equals 7 minus 10t I plus 5 minus 10t j. I hope you got it. Let's see next part. Hence, find the length of time for which the ships are within 2 km of each other. Take care of the difference. The question, the length of time in which the ship are within 2 km. It's okay. Not, question isn't not, find the time when the ship 2 km. I hope you got the point. Here we have the position vector AB, which is 7 minus 10ti plus 5 minus 10tj. So we can find the norm, as you know, square root, and first projection power 2 plus second projection power 2, which is equal to 2 km. It's okay. So we expand, we can put power 2 here and power 2 here, square both sides, as you know, and expand the bracket, the first bracket and second one, as you know, first power 2, second power 2, first by second by 2, as you know. Then combine like terms to get 200t squared minus 240t plus 70 equal 0. We can divide the whole thing by 10 to make it simplified. 20t squared minus 24t plus 7 equal 0. Then factorize this form. 20 will be 10 times 2. 7 prime number will be 7 by 1, and the last sign is positive, so we get two similar signs, negative and negative, like the middle, as you know. So we have either or, either 10t minus 7 equals 0, it means t equals 7 over 10, or 2t minus 1 equals 0, it means t equals half. So in this time and this one, the two ships at 2 kilometer apart. Ships is within 2 kilometer. We'll do subtract for the 2 times to get the length of the time. I hope you got it. Question 8. Three particles P, Q, and R have the masses 4m, 3m, and 2m. Particle P and Q are connected by an extensible string that pass through smooth light fixed poly. Particle R attached to the particle Q. The system held at rest with the string taut and the hanging parts of the string vertical. The system is released from the rest. Find the acceleration of the particle P and the tension in the string. Let's see how to solve it. So we can draw the system. Here 5m and here is 4m, as you see. So the system will move in this way. For the body for mass, the tension up and weight down. The general form of second law will be T minus W equal MA. W the weight equal mg, as you know, but m equal 4m in this case. So the equation would be T minus 4mg equal 4ma. For the side 5m, we can write 5mg minus T equal 5ma. Now we have equation 1 and equation 2. By adding to equation, we can cross out T from both sides. Now we have 5mg minus 4mg equal 9ma. We can cross out m from all parts. Now we have 5g minus 4g, which equal 1g. So 1g equal 9a divided by 9, so a equal g over 9, approximately 1.09 meter per second square. Now we get the value of a. We can replace in first equation to get t. So t equal 4mg minus 4m. Replace a with the value g over 9, its initial value, not approximated one. So t equal 4mg over 9 plus 4mg, which is 40 mg over 9, approximately 43.6 m Newton. I hope you got it. Number B, state how you have used the fact that the string is extensible. We can write easily two independent equations. At the instant when the particle P has moved distance d upward from its initial position, particle R separates from particle Q and falls away. In subsequent motion, particle P and particle Q continue to move, and particle P doesn't reach the poly. At the instant when the particle R and Q separate, particle B is at the point A, continues to move downwards. Particle Q then comes to instantaneous rest at the point B. Find in terms of D the distance AB. Let's see how to solve it. Also, we see in two parts. First part, before separating, U equal 0, G A acceleration equal G over 9, S equal D. Use the equation V equal U plus AT, A equal G over 9. So V will be G over T. It's okay. V, it will be U in next part. Take care, please. Then using the equations S equal UT plus half AT square. So replace, and for S equal D, as you know. So D will be half G over 9 T squared. I leave it in this form to make the second part easier, as you will see. After separating, the system still move in this direction for a while and come to rest. So V will be 0, V dash, new V, before and reverse its motion. So we write the equation for the two bodies. Still the motion for M move to up, so the equation will be T minus its weight, which is 4 mg, equal its mass by new acceleration A dash. So the equation will be T minus 4 mg equal 4 m a dash. For the body 3m will be, the equation will be 3 mg minus t equal 3 m a dash new acceleration. By adding two equations we can cross out t. So now we have negative 4 mg plus 3 mg equal 7 m a dash, gives us the new acceleration equal negative g over 7. It's okay. Now we have u dash, which is v in first part, equal g over 9t, v dash equal 0, s equal ab. Replacing the equation, v squared equal u squared plus 2as. Replace each component. Now we get 2 multiplied by g over 7 multiplied ab equals g over 9t all squared. We can write it in this form. Then I try to find the value of d. As you know, d it was half multiplied g over 9 t squared. I try to find this form which is d. It's okay. We can cross down g from both sides. Using inverse operation, 2 will be half. 1 over 7 here will be 7. It's okay. So now we have 7 and half, and g crossed out, so still 1 over 9. T by t is 2 square here. It's okay, 2 square, and g over 9 is still the same. And get the form half multiply g over 9 multiplied by t squared, which is d. And still we have 7 multiplied by 1 over 9, which is 7 over 9. So AB equal 7 over 9D. Now I've finished M1 Pearson EDEXCEL Jan 2019. I hope to see you next video. Bye.